All right, everyone. Mark. Welcome back. Today we're going to be doing textures and materials. The first time we did 3D modeling. I hope you guys retained the information from there. Let's get started. Before anything, I want to encourage you guys to, when you are trying to create a material, just to go out and find that material and shine lights at it and try to understand how it works, because a lot of how a material works you can see just from an image of it or by holding it even better. A little bit of terminology you're going to want to know. Basically, when you have a material, there are a couple components. Textures are 2D images, color or grayscale, and they are used either to show color or to drive some kind of function. Shaders are mathematical algorithms that create certain effects. You don't really have to worry about the math, just know how shaders are, shaded using certain calculations. For example, a shader would control if light is reflected, how much, if it's reflected in different directions, if it's absorbed. Also, bumps and normals and displacement, those are all different kinds of shaders. And materials are just basically the containers that hold your shaders, which are holding your textures. So if you look at this little image, I have these 3 shaders. One is a color, one is a bump, and one is my specular. Oh, sorry, 3 textures, sorry. And I'm loading these each into a different shader channel, such as reflectance or color or bump, and then they all are composed into this final image, which compared to using just a color texture, you wouldn't get 0 reflections on these little burn marks or on the cracks. It would just be a matte reflection. So it's important that you have these different textures working together, because just one isn't usually going to cut it if you're shooting for photorealism. UVing, this is one of the most important things in texturing that you are going to want to understand. If you have ever in like grade school, if they ever gave you like a T shape like this that you're supposed to cut out and bend into a cube, that is basically all what UVs are about. It's about taking a 3D object, flattening out to 2D so that you can texture it, and then kind of folding it back onto the 3D. So right here you can see how this face has been flattened out and how you could draw in contours where the chin is and draw where the lips are, etc. So that's how UVing works. I'll unwrap this one for you guys. So if I have a shape like this that I want to texture, it's a little different throughout programs, so it depends on what you're using, but the UV map is going to look the same. When you texture it, it's going to be the same. You're basically just drawing on it, whether it be in your program or in Photoshop. That doesn't really matter. It's up to you. So let's say I wanted to unwrap this shape right here. Oh, I already did it. Let me remake it. So I'm gonna start with a cube, just add some more detail so I can do some cool stuff with it. Alright. So if I wanted to unwrap this in my specific program, I would just it's kind of like a one-click thing. You click the unwrapping wizard, next, yada yada yada, and then hopefully now I have all these UVs set out on a flat plane here. And if I could export this this image right here into Photoshop, and that way I'd know, I could draw on each individual face that's made. If you are unwrapping some more complicated models, you're going to get some problems where part of your model might be, overlaying another part. So depending on how complicated, you might have to do some reorganizing in this space here. But if you are smart with your modeling and you don't add too many polys and only have your loops where you need them, usually the program can give you a pretty good UV to work with. So you can actually see right here, if I just grab a brush, I can paint here, and you can see the strokes going onto the 3D model in real time. Obviously this isn't a very intuitive way to do it. You'd probably be better working off of Photoshop, but it's the same premise, just drawing on a 2D texture to be then mapped onto a 3D texture, 3D object. Material systems. So each program is going to have a different material system. Usually you have a layer-based system, or a node-based system. They both, you can pump out the same material using each one. The workflow is a little different, and there are some advantages to other ones. For example, so here's a layer-based system. It uses a hierarchy, so basically kind of like Photoshop, you have a texture down here, and it's being, like you have another texture being multiplied on top. That's how the layer-based systems work. If I were to jump into a texture here, which in any of these, I have all my attributes, and in here is where I work with my layers and hierarchy and what textures are in. So very similar to Photoshop, you have layers and blending modes. So that's how layer systems work. Node systems, they are obviously using nodes with inputs and outputs. And this is a little bit harder to learn, but once you do learn, it's much more efficient. You can imagine I use a noise texture in a layer-based system. If I want the noise textures to, cooperate among different channels, in a node-based system, I change one node, and then every output from that node is updated. In the layer-based system, if I have a noise here, and a noise in reflectance, and a noise in bump, and I want them to all be the same, I have to copy-paste, change the settings, copy-paste. And anytime I want to do an update, I got to change 3 noise types instead of just one node. Channels, aka shaders. This is also very dependent on your specific engine, so I'm going to try to keep it broad and more in terms of the physics of stuff. Usually you can have a color channel, which in a physically based environment isn't actually accurate. A color channel works by defining a color, and then it's either brightened or darkened based on how much light is hitting it. And that's not physically accurate, because in reality, when light hits an object, you are seeing the literal light reflection. So sometimes it's easy. If you want true photorealism, you're going to have to use some sort of diffuse function. I'm going to show you that right now, actually. So if you look at these two, little things here, if I were to render this, actually, let me make sure it's set up. So I'm going to put a regular color material on this, and then a regular color material on this. And if I render right here, you're basically just seeing, this color and this color. But if I use the physically accurate model, which is basically saying, instead of brightening this color, reflect this color, now I'm getting this kind of color. Oh, you can't really see on the. So basically, the blue color is being reflected onto the floor, which is how light works in the physics world. If you were to hover your finger above like a very bright surface, you would see a little bit of red spill onto your finger because the red light is being reflected. Let's see. Reflectance and specular. This is also very, very dodgy when you're trying to compare different render engines, because some render engines define specular and reflectance differently, whereas some combine them, which is how it should be. But basically, it's either the reflection of light sources or the reflection of other elements, like I was kind of explaining before, how the blue light was being casted over to another object. I'll show you the little differences here. So let's say I was working with the non-physically accurate model using only color. Right now I'm working with just a specular shader, which is not physically accurate, but it can do the job depending on what you're doing. You can see raising here, I'm literally just changing the reflection of the light I'm using. I'm using a point light. So if it's a really tight specular, I get a really tight, clean reflection of the point light. If I were to change that point light to an area light, oops. Actually, hey, it doesn't work because Phong, like I said, is not a physically accurate model. It's just using a lighting trick to simulate the reflection of a light. Luminance and emission. This is basically saying I want my material to emit light, to act as an emitter or a light source. Oftentimes in render engines, you're actually not going to get any light spill just because of how luminance works. If I were to just put regular luminance on this material and put it here, it would not light my floor, because without a certain thing called global illumination, it's not actually bouncing light. It's just saying, oh, I hit this material, and it has this amount of light coming off of it. It's not actually doing that without this little thing called global illumination, which I'd probably go more into next tutorial. Transparency and refraction. This is where you're going to be making your glass materials. So far, I've been talking about light being reflected, but obviously, with the transparent materials, light is reflected and refracted, meaning it bends when it hits it, and we don't know how glass works. I'll do a little demonstration so it'll be a little more intuitive. But let's say I have that guy behind that guy, and I put transparency on. At 0, at a refraction of 1, nothing's actually happening because the light is not being reflected. It's refracted. It's just casting right through as if it was nothing. Once I start raising the refraction, you see what start to happen. Light is actually now bending. So if I were to render this looking through like there. Oh wait, sorry. Now the light's actually being bent, so you can see the sky is bending through and showing on the bottom, and the sphere is slightly offset. Alpha, don't get alpha confused with transparency. Alpha is quite literally just whether or not the texture is visible or not. So alpha can save you tons of polygons modeling. If you imagine a chain link fence, you can model tiny tubes intertwining, or you can just put an alpha texture on it that has some kind of cross hatching on it, and that would hide the texture only where the holes in the fence are. Let's see if I have an alpha texture. Let's see. Like here's a nice alpha texture. If I were to take this texture, is just a black and white texture. White meaning completely visible, black meaning completely invisible. Just drag that here. Oh, you can actually see what's happening now. Oops, whoops. So now we can see through the texture, and we only have one polygon in this piece of geometry, yet we have all this detail. And obviously, there are very specific applications. If you're going to have a scene where you're going to be right next to a fence, you want to have some depth. You don't want it to be a flat plane with just an alpha texture. And then bump and normal displacement. This is what's coming up next. Okay. Oh, actually, it's not next. I'll get to that next. Where is it? All right. Bump. All right. Bump maps. Bump maps are basically grayscale textures that you load into a bump shader, and it will simulate virtual bumps. It's not actually adding any. It's not real detail. It's all just basic lighting tricks. If you've ever done any retouching in Photoshop, you can add a contour to someone's face by adding a highlight on top and a shadow on bottom. That's basically the same thing. It's using the grayscale value or the grayscale texture to define a height so that it can get some shadows and some highlights on top. But you gotta remember that the detail is not real, it's just texture, and it's compared to the other kinds of mappings you can do, it's very primitive. You're not gonna get realistic light reactions if you're moving around your scene, but it adds a lot of detail. As you can see, like in this texture, it adds all kinds of micro bumps that you would see. Normal maps, which are the next one, are one of the most powerful maps. They also simulate detail, but instead of using just a black and white image to kind of define height, it uses a complete color image, and it uses those images to tell your renderer where each part of the surface is pointing. So if you look at this map is using reds and blues and differences to define cracks and crevices and hard edges. So that's the real topology in the middle. It's just a triangulated, low poly, very smooth surface. But when you're adding these normals on them, it's now telling the render, use this detail instead of the mesh detail. The mesh is just acting as a boundary for your normal map. So if you look on the edges, the actual mesh doesn't change around the edges. If you were to use a really low poly one, you would get these crooks at your edges, although you still have all that detail. So you kind of have to find a balance. This is a really good example because that is an extremely optimized texture. It's got like less than 100 polygons, but it looks photorealistic because it has such a good normal map. You can kind of follow this edge right here. It's not existent here, but in the normal map, you can see there's this bit of detail that's making that edge along here. And the last one is displacement. Displacement, you can do tons of things with displacement, but it's very heavy compared to the others. What displacement is doing, it uses either grayscale or color pictures to literally tell the renderer, okay, this polygon, it's going to be literally raised up at render time, the maximum value, if it's white, or the minimum value, if it's black. So this picture right here, the white texture you're seeing on the right, that's the displacement map, and the left texture, that's what's being rendered based on the displacement map. Usually it uses some kind of method of subdividing polygons called subpolygon displacement. So at render time, if you have a square, it'll say, okay, subdivide this 4 times and use that detail with this map to raise the surface. So I'll show it in viewport so it's a little more intuitive. If I have a plane, I actually showed this last time, but I'll show it again. And I have, actually, this here. So I just have a simple noise texture on this plane being and acting as a displacer. If I render it now, oh wait, I don't have a light, sorry. If I render it right now, it's going to be, very, actually, let me raise this up a bit too. So I render this here. You can see it's very jagged. There are no smooth edges, and that's because the mesh I'm working with it does not have a lot of polys. If I lower this even more to 1, you'll basically see all I get is like one crooked polygon because that's all I'm working with. However, in the displacement channel, this sub-polygon displacement, if I check it on and say, subdivide it once. Now I have 8 polygons maybe. If I subdivide it twice, now I have, the next power if I subdivide it 8 times, which is, a lot, but now I have some detail to work with at render time. Subdivide, I think the highest is 16, now the highest is 12. So obviously you can tell it's already taken quite a bit of time. It's preparing down there. And now, render time has come to a complete halt, so I don't recommend moving it up to 12. Oh, there we go. Now it's got something. Okay. Oh, here's another little example. You can imagine having, a folder with one 3D file with your huge multi-million polygon mesh, and it's 10 gigabytes. It takes forever to send. Or you can have, a folder with one low poly optimized mesh and your detail textures, and that's 2 megabytes. And the result is, basically the same. So you got to think about, your resources and what's the best way to do things. Some effects that you should probably think about, because not all render engines work physically accurate, and you're going to have to use some post effects to get what you want. Subsurface scattering, that's a big one that a lot of materials are affected by. Basically, that's like your candles or your skin, where if you shine light through, you'll see kind of the light coming on the other side. I have an image somewhere. Right here. So that's also referred to a medium in some render engines. You can define, basically, I want this form, I want the light to scatter this much and at this speed, and I want it to basically cancel out at this length. Those are the kind of parameters you have when you're working with subsurface scattering. I think I missed a couple slides. Okay. Another effect, ambient occlusion. I think I also talked about this last time. Basically, where there are cracks in your object or crevices where natural light it's harder for it to hit, it'll be shadowed. You can use that as a shader for a model. So if you have some super high poly model that you didn't want to, or not even high poly, you can see if I take a model and I just add some geometry to it. Whoops. Oh crap. Okay, so if I took this model right here and I put a subdivision, an ambient occlusion filter on it, let me just put in the luminance so we can see it. Ambient occlusion. If I just slap that on there, actually let me put in the texture, or the color channel. Crap. Good example. Hang on guys, sorry. Okay. So you can see here with no lighting or no texture or no like color or anything, I have these shadows at the edges and in the pockets, and that's from this ambient occlusion shader here. It's basically just doing the same thing a render engine would do when it's calculating ambient occlusion and ray tracing edges and seeing if where there are tighter hits, and it's adding detail there. And you could use an ambient occlusion shader, this black and white texture that's being generated, to drive another texture. So oftentimes what people do is they'll use this this filter, which is when you kind of export, when the render engine is dealing with that at the end, it's just another texture, a black and white grayscale texture. You can use that to drive a luminance, which can kind of fake subsurface scattering, which if you do render realistically, it takes a hell of a long time because light is entering objects and bouncing around and leaving objects and going back in objects. So, there are a lot of smart ways you can simulate effects a lot quicker than if you were to work realistically. No, yeah, I know. My thing was a little out of order. All right. So I'm just going to talk about this a little bit. Typically, you have three types of surfaces in terms of how light's reflected. You have diffuse surfaces, which light hits it and is reflected in all directions, basically the opposite of a mirror. You have glossy surfaces, which are the smooth surfaces, which reflect light in the primary direction, the most perfect example being a perfect mirror. And then you have the refractive surfaces, like I said, that reflect and refract light. And the interesting thing that is really cool to think about is that if you were to take a perfectly reflective surface, like the one in the middle, and just raise the roughness to 100%, you would eventually get a diffuse material. Because quite literally, all it's doing is saying, light's hitting perfectly, now hit a little more, and a little more, and a little more, until you have this reaction right here, where light hits a surface, it goes everywhere. And this was a pretty good little read up on it. It says, in the real world, surfaces are made up of an innumerable number of microscopic reflective facets, each with a different orientation, which can be from distance, reduces spectral highlight, or reflection. You can see the first one at the top left, that's zero roughness, perfectly reflective. But as we add roughness, more and more roughness, it starts to look like a diffuse material, because basically the only difference is these micro bumps that are scattering light in different reflections versus in a single reflection. If you can kind of wrap your head around this concept, the creating materials, it becomes completely different, because now you're thinking about how light actually reacts and how it should. You can actually art direct more specifically instead of just changing parameters hoping that you'll get closer to a plastic or to a rubber. Instead, you can look at plastic and rubber and say, okay, the light's doing this. I can see a very blurry reflection of my light source, which means that obviously there's a little bit of roughness, but I can also see this perfect reflection on top. So maybe it has a clear coat on it, such as a car paint. A car paint is just a bunch of layers of different reflecting materials, one being a color reflector, one being a clear coat on top that's just reflecting a perfect, almost mirror reflection. So it's helpful to just look at your materials and break them down. Did I miss anything? Oh, some photorealism tips. One big thing is avoid extremes. So if you're modeling paper, don't make the paper 100% white. There's nothing that's literally 100% white. I think paper is more like 92 or something. Also, no black. There's no 100% saturated colors. If you ever get to the point where you're working in a physically based environment, if you have 100% saturation or 100% white, your light ray is going to keep bouncing because it's effectively not losing any energy because it is 100% reflective, which is not exist. You can also use a lot of noises. No surface is really perfect. Even a mirror, you can use a noise to drive very small variations in how much is being reflected. And that can add a lot of realism to your renders. So like if I wanted to have this sphere, so I have this sphere and it's reflecting the environment, I could just add a very slight shader in here, like one of these noises at a very low intensity. Other way. And here you can kind of see it's, oh, too much. It breaks up the reflection slightly, and I could even probably go less than that. Like this, maybe. Ah, see? So you see what's happening. That's a good way to add, the dirt or some kind of lumps. I could even add that same one in the bump channel ever so slightly, and that'll ever so slightly kind of change the way things are reflecting. Here's another good example of how one texture driving one parameter can make a huge difference. If I wanted to make a realistic water, I think 1.33, if I were to just put this on here right now, this is what I have. Well, let me put something underneath it. So that's what I have right now. Obviously, there's some refraction going on, but it doesn't look like water. But if I were to add some bump to it to start messing with the reflection so light is hitting differently, now I have this, which is much more interesting. Try to lower that even more. Now I have this right now. It's even crazier. Anyone have any questions? Anyone want me to go over something? I know that was a little sloppy. Just because of the nature of how different material systems work and everything.
Didn't seem sloppy to me.
Thank you, Mark.
To me, it seemed pretty concise. I liked it.
Anything anyone want me to go over more specifically? Want me to make anything?
Go over UV maps.
You want to go over UV maps again?
Yeah.
Sure. Oh, hey, Mark. Other Mark. All right, so let's.
I'm sorry, what program is this again?
This is Cinema 4D.
Cinema 4D, okay.
All right, so let's see. What's something cool we can unwrap? Let's see. This will be an interesting one. All right, so I'm only going to work with this body. I don't really care about everything else. Okay. So this is already all unwrapped, but let's get rid of this and this, and let's see what our program does when we first unwrap it. So if I just have the object. And I do the unwrap magic. Alright, so this is what it gave me. It's not bad. typically you want this edge to be complete. You don't want these cuts out. But you know, this is workable. If this model was something you were going to be using repeatedly, you'd probably want to go in and find the edges where everything is supposed to be and connect them. So you can do that. Like, I can see that this edge is this edge, and I want the one right next to it, which for whatever reason has come over here. So I could grab this one and pull it and connect it here. And that is probably where all the tediousness of UV mapping comes from. It's cleaning up the generated map after you bring it out of your program. But like I said, you could work with this. So if I wanted to, typically how I bring it into the next program is I'll select it. I will make a new layer that I can then outline my polygons with. And then I'll save this. Oh, actually, I made a little goof. I meant to save it as a PXD because right now, since I'm working with layers, if I save it as a JPEG, I'm not going to be able to disable my wireframe I made. So PSD layers. All right, load this in. So now I have this in Photoshop, and I can toggle this on and off, or work at really low, just so I can see where my body is. So I believe this is his back. So as an artist, I'd probably, well, if I were really painting this like a person, I'd probably start off with like a nice skin tone right there, and I'd fill the frame. And then that's when I start painting in shadows and details and where lips are and everything. Which in this case, it might be lost in one of these. Actually, I'd probably have to go back here and go to my model, grab his lips, and see where the texture puts me. Alright, so, oops. So obviously his lips have ended up, here's his upper lip maybe? Yep. Lower lip? No, upper lip. Yeah. So if I were to paint on this, you could see my my cursor coming up in 3D view. And then, I mean, from there, once you're done painting in Photoshop, you just resave it and load it back in, because this kind of space is already coded into your model. So just putting in a new texture that the detail lines up with defines, it'll map it. And some areas are obviously much easier to work with, like this back right here. I can easily see that I can paint up and down his back. Oops. Oh, Jesus. Yeah, see?
I'm not a fan of that sound.
I know. Yeah, I mean, that's the basics of it. You could go, although, once you're UVing, you're making a color texture, you're making your normal texture, your bump textures. These are all different UV maps that, the same maps, but they're going to be vastly different. Let me see if I have any fully textured things. Actually, I do. School, arena. So in my most recent project, which was some coconut thing, I had to do the same process. I exported out textures. And this was my diffuse texture, this was my displacement texture, and this was my bump. And I had a normal, which is right here. So, oh, whoops. If you zoom into this, oh my God, you can really see how much detail it's actually putting into my model. Here we have like tiny little bumps and a bigger gap. And you know what? One more helpful thing, actually. any texture that you find or take a picture of or make, you could load into Photoshop, and you can generate bump in normal maps from it, depending on your version. If you have the most recent version, or at least CC, under your filters 3D, you have this generate bump and generate normal map. If you click it, it'll bring you to this interface where you can actively see how lighting is changing based on your parameters. If I say I want, tons of detail, you'll get much sharper edges and everything. I can also do the same thing for normal map. And as you see right here, it generated this, this high detailed normal map. I have this huge crack running down and all these micro bumps. And I could pan around. I think I can change the lighting too. I'm not sure how. Here we go. Hey, you can see how light is reacting with the normal map. And then that can just be exported and put right into your program as a texture. Yeah, I mean, yeah.
What about
Displacement map? That's a little harder to do in Photoshop. Honestly, the bump maps that come out can also be used as displacement maps. Let's redo it and just check out what it gives us. So, I mean, yeah, this could be used as a displacement map. Typically, you can also just fix it up by doing some levels adjustments. If you can kind of think about how this is going to translate to a displacement, you can make much more logical tweaks. So, like, if I really want to really blow out these darks and the cracks, I can do so with some levels adjustments. And obviously, this would probably make a much better displacement texture than the one without the adjustment, because it's a little blurry. The rocks wouldn't be as sharp. But if I do this, now I have all this tiny detail that I know the displacement map will work well with these really heavy cracks and then all these bumps. So let's see how that works actually. Let's just put it in. Oh crap. One sec. Alright, so let's do this. Let's do this interactively so we can watch it happen. I'm gonna give myself a displacer. I'm gonna put that texture I just made in there. Okay, so you can already see some stuff happening. I don't have enough polygons right now, so let's make it 200 by 200, and now you can really see what's happening. We're getting those cracks that were the really dark parts, the full black parts on our texture. Let's raise the height a little bit more. There. If we add some even more polygons, like 800, obviously it's getting a little bit more out of control, but you can control this. You can kind of fix this in Photoshop just by limiting your values. Say, I don't want any of my whites to reach absolute white, or you can also limit it in here, I believe. Let's see. Alpha. Or actually, this can even be fixed with a fall off. Whoa, that's pretty cool. That's not what I wanted Here we go. Lowering the white point kind of fixed some of those peaks a little that I was getting. Fix it even more. But you get it, right? Anything else? No? You want me to make? actually, I'll talk about one more thing. When you're, this is another way to make displacement maps like you were asking. If you model something with super high detail, let's say I had that classic Red Bull can I made. I'm just gonna make something really quick. Let's just say I had this with a bunch of so let's say, like, for whatever reason, this was your high poly model, and you wanted a displacement map so that you could, use displacement and be more efficient. There's this method. There's this process called baking, which basically is you take a low poly model, roughly the same size as your high poly model, and what it does is it will ray trace. It'll cast rays from your original poly, just see where it hits the high poly mesh, and that's how it calculates your displacement. Again, the process is different throughout programs, but let's see how it works. So this is my high poly, and this is my lower poly. If I put a big texture on it, just put some filler materials on. Displacement. Nothing. All right, hang on. Nothing. Oh, this is why. Nothing. I would probably have to think about this a bit more to get this to work, but the function is the same. You have a high poly model, low poly model. You just tell your renderer or whatever your program how it handles baking. Just tell it use this high poly reference and calculate a displacement map based on this low poly frame. You can also do the same thing with mobile maps if you wanted to. You have to calculate that out. Anything? Questions?
So you finish your model, you have a lot of polygons. How would you reduce the amount of polygons that was in quality and simple?
How would I do that? Well, that would be basically what I just said. I'd if I had let's say, actually Cinema 4D probably makes it a lot easier. Like, let's say that's your high poly model, and you wanted to bake that onto a model like that, or even less than that, like that. I mean, obviously, you're not going to be dealing with this primitive where you can just lower the segments, but most 3D programs have some kind of polygon reduction command that if you toss it in one of these, you can lower the polygons based on some parameters. So what I would do is I'd just take that high poly mesh and I'd lower it until I felt that it had enough polygons where it was manageable. And then I do the same thing I was just talking about. I just bake the detail onto the low poly, either normal map or a displacement map.
What is baking?
Bake is basically it's looking at your texture in 3D space and exporting it to a 2D texture. So I mean, in terms of displacement, it's not actually doing anything with textures. It's literally casting rays from your low poly model into your high poly model, seeing, oh, I went a little deeper here, and then I hit closer here, so obviously there's some sort of Ambient. So that's how the baking actually works, just by ray tracing between models.
Would you say baking is like the pre-rendering a texture?
Yeah, that's a good way to put it. If you have a completely rendered texture that, like if you made a texture out of just noises and a bunch of generative stuff, and then you bake that, you're taking all that noise data and saying, okay, now I just want a picture. I don't want any of this procedural, parameter stuff. I just want a flat texture. Baking would do that.
What are some good textures that are worth baking?
Good textures worth baking?
Like for like certain materials, like fabric is one of those.
Fabric?
Folds.
Fabric, yeah. If you have, honestly, you're going to want to bake anytime you're working in a game engine like Unreal. quite 100 million polygons, but it can, read a normal texture for its lighting information and then do that real quick. We'll talk about 32-bit stuff too. Raw photography. Last call for questions. Here, I'll show you some inspirational pics. Yes, but they're textures and light happening here. Actually, I have something cool to show you. Watch this. Skin displacement map. Which is the one I like looking at. You can, this texture, to make realistic skin, you can put a displacement texture on it with just 0.01 max height, and it will take your skin to a completely different level. Because that detail is there. I think this is, I was about to say, is this a render? I don't know. I'm just kidding.
Probably.
I'm just, that's what I was saying. I just realized, there's no eyes in there, of course. Displacement, bumps, maps, normals, they're all beautiful. Oh, look at that one. Ooh. Oh, is this the same one? Probably. Oh. More pictures, guys. Look how beautiful they are. Wait. Look at that. The car paint.
So something else that really mentioned, but is still kind of important, is depending on the texture you're using, those textures can be generated in the software you're using. But if you need to get an image, depending on what it is, it's really important to have seamless textures, because otherwise you'll get tiling effects.
I have a quick way to show the difference in that. Alright, so. You're right, Monica. Alright, so let's say I had this cube. I usually make all my textures in Cinema just using the layers and different noises and overlaying and using noises to mask other noises and stuff like that. That's tons of detail you can do right in program. But let's say I just wanted a noise. Oh, that's not a noise. That's a gradient. Alright, so right now this noise is being generated procedurally in Cinema. And when I render it, I actually don't even have to worry about UVs because when you're using stuff like this, it's using a different space. This space is called texture space. If I were to change this to UV space, then basically it's taking this texture right here and just duplicating it on the UVs. And when you're doing it like this, you get the same texture on everything. But when you use kind of generative stuff, you can do it in other spaces, such as texture space. You can project things as a spherical texture, which kind of means that the texture will shoot its rays out, and then wherever it hits the model, it'll map that part there. So that completely negates UVs. There's also cubic and cylindrical stuff. Like you would never have to UV map a can texture because it's just a cylinder map. You just set a plane to map cylindrically and it'll wrap around the cylinder. Let me see if I can make this more apparent that it's duplicating. UV space. Yeah, there you can see. Blob, circle, but in texture space, now it's just kind of putting this noise field around my object and getting the texture to do that, just based on what value is floating here on this object and what value is floating here. Those are completely different space. Oftentimes, once you get too complex with your materials, you're going to start noticing how your topology isn't going to allow for certain things when you're working like this. If I were to pinch this, or let's see, taper. it's actually doing well. If I change this to UV space, you can see how topology is starting to morph my texture. You know, if I want it to be a uniform texture that's not stretched, you know, I might have to do some UV mapping instead and just make sure on this polygon it's painted perfectly straight and not being deformed in any way. So, you know, it really depends. You gotta think about it. Anything else, guys? I'm here for you.
Textures are really fun kind of messing around with. Guess how you can technically experiment with them is definitely cool effects. Something that I believe is unique to Cinema 4D as opposed to 3ds Max is you can actually layer different textures on top of one another. So if you want to do like
3ds Max uses those, I think, right?
yeah.
Yeah, so, yeah, different layer systems.
But like if you wanted to do like a dust and shell, you could have one layer of texture that's just like a wood texture, and then the layer on top of that could be like a dust texture. And it would be two textures applied to the same thing over each other.
In Max?
Yeah.
Yeah, I think you can, in Max, it would probably be more like I have this noise node, and then I'm multiplying it on top of this noise node, which is then feeding into this texture, which, you know, might be more confusing, but, you know, if you're dealing with, again, 30 different noise types, and, you know, you don't want to have to hard correct each one. Oh, you know, I like this at 50%, set 51, now I got to change it 50 to 51 30 different times.
Max has it's got a node-based system and I don't know if it's a layer-based, but have you ever used Max? It's got like the node and then the sleeve.
Kind of like this. Like this.
Yeah, so Max has a node-based system which looks like this, where you have your texture and you have different channels for
Yeah, so
types.
you know, noises.
Use normal displays with that too, stuff like that.
This breaks it down a lot. Like from right here, I mean, it would not map correctly. I need a UV transform, which is basically telling this noise, all right, be mapped in this kind of space, and then I need this projection, which actually no, the projection does the UV thing, and then the UV transform, that's like scaling. So everything is separated, but if you ever do start using node-based systems, you'll quickly learn where it's really advantageous compared to the layer-based systems. Yeah, so like mappings, you have this multiply node, and then now it's like kind of like Photoshop, you know, textures being multiplied on textures to get different effects. Then load this into the fuse.
One's more visual, and one's more organized.
Yeah, the layer one is definitely easier to understand from the go. Much more intuitive. It's a color channel, and you can see all these textures on top of each other. Whereas this is, you know, some real crazy materials can get, you know, absolutely bizarre looking in the node port. All right, look at this. What's going on here? You have like this map with 8 different nodes going who knows where. And this might not even be a material. It might be like a function for defining metals or something. It's a material? Satchel, read it to us. Read it, Satchel.
The normal map on the bottom left is a merged texture, which means they wrote different textures into each different color channel of the normal map, which is really good for optimizing memory usage. I don't know this one stuff.
But actually, that kind of reminded me. Do you guys understand how normal maps work? Like when you render at render time? Kind of. Okay, well, I'm gonna try close to that for shading, when it hits each polygon, it calculates a normal, which is basically the perpendicular line or vector that's coming out of that polygon. The polygon's here, normal this way, it's here, normal that way, etc. Normals basically say, forget the polygon normals. Now use this color data. So wherever it's most red, oh, the normal's pointing that way. Where it's blue, it's pointing that way. Where it's green, it's pointing this way, this way, this way. So you can tell that obviously makes render time much faster, and you can have because all the normals are coded. You have this sheet of directional data that the render is used to instantly because it's a texture. You got all that 3 megabytes of color information. It's doing all this for your render engine that without a normal map, we have to do through right in tiny polygon and here, here, here.
Alex, can I ask any question?
Sure.
How do you scope hair and
How do you sculpt hair?
yeah, simply?
Don't.
Is it like a specific tool? Because in ZBrush you can use the fiber mesh, and it's like you get like a bunch of realistic fibers for the hair, but you can also sculpt it.
For a game engine or for just
Some
Photorealism?
rendering.
Well, I mean, I use actual hair module, which
It's like a function.
Okay, explain that.
how the hair works. Usually all the hairs work the same. It'll take a point on a surface and then it'll shoot a vector out based on some rules like this length, this amount of randomness. And then those vectors are going to be guidelines for your hair.
Show me some architectural graphs.
No, I don't use architectural graphs, Barry. Alright, so like if I had this, just put a hair object on it. Right now it's shooting, it's set to vertex mode, so it's shooting a ray out of my vertex to a length of 100 centimeters and using this as a guide, and all the rest of the hair is going to be interpolated between the guides. So obviously 45 degrees this way, 45 degrees this way is going to give me a line of hair that kind of goes like that.
How would you shape that?
How would I shape it? There are a lot of ways. Usually I like to do this first so I can see what's going on. You can shape it just through your material by adding like frizz and adjusting these sliders how you see fit. Less frizz in the middle, more at the end, stuff like that. Or you can grab a brush, like a hair brush, literally. Simulate hair brush, and then you can paint stuff like that. Look at that, that's cool. But you gotta remember, right now I only have 8 guides to kind of interpolate between. If I want more detail, I change this to area. Polygon area, now I can have more guides, and now I can paint all this detail just on one texture. And now we can do that and that. I can add more hairs. $50,000. And then, yeah, mark from here. I mean, you just have to be a hairstylist. Beautiful.
Can you go back to the human model and actually do like a figure or something?
Okay. Whoa. Alright. Here's our dude. I'm going to turn that off for now. I'm going to select just the top of his head. Too much here. And then I'm just going to grow hair out of there. Boom. Alright, so let's see what we got first. Alright, this is what we got. By the way, hair's dynamic. Woohoo! Okay, so if I actually want this guy to look good, obviously, this would have to be more like... Oh, that's number guy, sorry, right here. More like that. And there's this cool function called the comb, which lets you kind of orient all hairs towards a certain direction. If I apply this, everything will bend back like that. Obviously this hair is not where it needs to be. It's too thick at the end. Probably too thick about the whole thing. So it's the 0.2. Even thinner. Alright, so now we got this super thin hair. Let's in the material I'm gonna add some a little bit where's the length? I'm gonna add some variation in length, like 20%. I'm gonna add a little bit of frizz, why not? I'm gonna add a lot more hairs. $50,000. Alright. I'm gonna turn on just some basic lighting. Let's see what we got. We got some hair on her dude. Kind of. It's almost like an afro one. Ugh. Yeah, so obviously that comb, that one button comb, all hair going back, it probably isn't going to cut it, but you could go in and, you know, paint your hairstyle you want. You want to have some wings come out like I do, or here, you can paint that. You can turn them, crap. You can do some even funner stuff like this. You can really give them, oh whoops, let's give them some more hair. Let's give them 10,000. Let's put it. Look at him, he's in a light breeze now.